Oh look, it's another soundbar. This one's JVC, model TH-BY858Z. And apparently it doesn't turn on. So, let's see if it doesn't turn on. I will plug it in. Is there such a thing as a standby light? No, I don't know if it should have one. I know nothing about this. We have a remote. And if I push the power button, nothing happens. Is the remote dead? We have batteries. Let's do a quick check of the batteries. And I can tell you battery number 1 is 1.5 and battery number 2 is 1.5. So not a problem with the batteries. Does it respond to touchscreen? No respond to touchscreen. So it's clearly brain dead. Or maybe the power supply's given up. Oh, hello. The power supply's a DC jack. Ha! Let's just check that. Do we have voltage coming out of it? And we have 18 volts, which I assume is enough. What does it say on the back? Must be 18 volts. Yes. Okay, so that is good. Now we get to open it. It's the best part. A few screws, plain old Phillips. Okay, so there's a screw under here, and I thought, why would there be tape across there? And then I thought, this kind of feels like maybe an original, you know what they stick across the front of it to keep it looking good and when it's packaged and whatnot, and you've got to peel it off afterwards. Well, it's stuck over the back, and look, it's actually covering all of the air vents. Like, that was a silly move, whoever stuck that there. Plus you can't hang it on the wall. But yeah, it's covering the air vents, so maybe this has suffered an overheating. Maybe. Let's take that off. Screws out. Is it clipped or is it just going to fall apart? Nope, it's just going to fall apart. Okay. There we are. With a flex to the front panel. So, at least we can kind of get at everything. Obviously power comes in here. There's a DC jack connected down there. We'll make sure that's still attached to the board. So we're plugged in, and we will check the back of our DC connector here and see if we have our 18 volts, and we do have 18 volts there. Ground on the bottom pin and positive on the left side, because that's the center of the connector where it comes out. Then it runs over to here, and something's going on here. I thought it looked familiar. Pretty sure I repaired this once before. I wonder what the problem was. So there's a wire link from here to here, which I kind of recall having to put in, and there's a resistor here, but I'm not sure if the other end's on ground or not, but there's 18 on one side and nothing on the other, so I guess I'm going to have to take this all apart and relearn how it works to figure out what happened last time. So last time we had a trace burn up or something. Yeah, I think it burnt up. There's a couple of caps on there that got destroyed, so we rebuilt that trace with a bit of wire, but not too sure what else we did. So let's have a look over the board to see if there's anything else that catches our eye. I mean, that IC there kind of looks like it got quite warm, just looking at the colouring of it. An IC up the top there that has the numbers etched off. And they don't want us to know what the secret chip is. Has its own oscillator and the red antenna lead comes in there. So that's some kind of tuner. Is that the antenna for the tuner? Could be a Bluetooth receiver. I don't think this has radio built in. We have possibly a LM358, sounds like a MOSFET. There's our processor. It's an ARM of some sort. Oh no, there's our Bluetooth receiver down there. So yeah, at the moment nothing really jumping out at us. Another flex connector. Oh, it's not burnt, it's a black vivid marker there. There's our amplifier IC. That's cool. That's similar to the amplifier ICs used in some car audio devices. Well, that looks okay. I think they class D. There's our output inductors, series inductors. Oh, hello. Does that look like a problem? Looks like a problem to me. We have a component that appears to have got so hot it's desoldered itself and tombstoned off the board. It's actually standing up off the board. That top should be down on the board, but it's pointing up at us with the bottom half on the board still. That is not good, and that's an inductor, a tiny little inductor, so who knows what value that would be. I wonder what that's doing. There's a capacitor there. There's a IC 14, could be a LDO, some kind of linear regulator. Oh, there's a big diode under there. Ah, there we go. There's a switching. There's a coil there. So it's almost gonna say that's a switching regulator. Okay, so best case scenario, we reattach that inductor and it works. Worst case scenario, it's toasted. We could look at the back of the board. I guess there might be something going on there that gives us half a clue. Probably a good idea. Let's get this board out of the case and we'll have a closer look at the other side and make sure nothing's tying in with that. So here is our DC jack and the trace coming out of the end of it. This is our positive line. So we've got our plus 18 volts, comes all the way along here. We follow that up and it goes all the way up into that 25 volt capacitor. And given the damage and knowing this guy, I'd almost guarantee he's plugged in the wrong adapter, and there's been a reverse polarity situation which has caused it to go up in smoke. It's a bit harsh. He may not have done that, but when faced with the evidence, what do? Let's just be funny and see if we get a resistance reading on it. So, looking for the beep. Oh, do we have a beep? Do we have a beep at the bottom end? We do, so our charred connection is making connection. Do we have a beep at the top end? What's left of it? No, nothing. Yeah. It's cooked. There's nothing left of it. So that will probably come off and Take the pad with it by the look of it. Yeah, this is a 1 0 and 4 zeros, so 100,000 ohms. Let's see if it still is. It's in circuit and we've got 27k, so that's alright. And this is a 39k in circuit and it's measuring 24k. Okay, it's fine. What about across this cap? Do we have a short? Is it given up that badly? Oh dear, we have a short across that cap. It is entirely possible that that cap shorted and pulled full current across this. The power supply is capable of at least 3 amps. Well, whatever was plugged into it, we don't know. If it was plugged in reverse, we would have possibly got that situation. I hope my regulator's okay. Otherwise we have to figure out what that is. Might be able to work out what it is. I'd almost say this is for generating our processor voltage. But we need to find out why we have a short here. Could be that cap. And yeah, it might be just easy to take the cap off and test it. Go from there. Do you have a short across this cap? No, it's a different ball game. This cap? No, good. Well, that's a good sign because that's on our regulator too there. So, yeah. All right, let's do that. We'll take that cap off. Now, if we still have a short, we'll take the reg off. Oh look, there's a little bit of solder just floating around here. That's always good to have in any product, just chilling and causing havoc. We'll keep the hot air off it because it's right close to that electrolytic. We don't want to melt the covering off it and cause any other issues, so we'll just flood with a solder. See if we can pick it up off the board. I need a bigger workbench. I just need to be more organized, to be honest. Watch that other wire. Don't want to melt that while I'm in here, under here. And there we go. Did I take it off or did I just bury it in solder? There it is. Oh, look at that. No short, and if we go to here, shorted. So here's the theory. Two theories. A, the cap shorted and pulled full current through our poor little inductor. Or B, he plugged in the wrong polarity from some other power source, which set it all in a chain reaction. Let's see if we can take the inductor off without destroying the pad. Probably not likely. Oh, there it goes. That's probably nothing special as far as inductors go. It's just possibly input filtering for our regulator, because it's not a switching inductor. So do we really care? It's being an audio device, it's probably just there to try and limit switching noise off the input supply that may come through the amplifier, is my guess. So shall we remove the main cap? I'll just give it a clean. We'll see if we can see what we're working with. May not have to. It's pretty cramped down there. So I reckon we drop a wire link from there to there and see if this thing still works as it should. Maybe run it up on the bench supply so that we can monitor the current, because we don't want it to take off and melt something else. But there's no short there anymore, so I don't think it will be an issue. And I would just double check again to make sure I wasn't getting a bad connection. Yep, no, we're good. We are good. Some of the mask off, and that goes, it comes through the inductor into this resistor, so we can just link that together with a bit of wire in the meantime. And we can see if we can hear any horrible switching noise, because I'm sure it won't really matter. It's probably just done for compliance, EMI compliance. Where is the, we'll use a bit of that maybe if we can fit it on. It's a bit thicker because we want it to pass a bit of current, so we'll use that one. Strip back some more of the coating on it. Whoa, blurry. Let's come down here. That's alright. A little bit of the old flux. This is not Amtech, this is Amtech knockoff from a seller on AliExpress. I don't know what they make it out of, or if it's even the same. I know people have done videos on comparing the stuff. Everyone says that Amtech's the greatest, and I've not used it, so I can't comment on whether it actually makes that much difference or not. But this actually works really well in my opinion, so I don't see any need to spend the amount of money that the original Amtech is. And I didn't buy it because it says Amtech on it, even if it is a knockoff. But I just went for something that looked that a physical appearance was similar. Seems to last too. People say flux has a shelf life of whatever it is, but I had some for a couple of years and it still worked absolutely fine. So I just want to try and break that off. There we go. Of course, we don't need to add that cap back in. That would have formed just part of the filtering for the input voltage. Let's double check for short. Ground to our input, nothing. Cool, so no short there. Okay, let's get a feed in from our bench supply. And what am I going to use for that? I've got a bit of little plug here I can use. Right, so we have a plug in with some wire there, bare ends, so we're going to hook that up to our bench supply. Maybe about an amp current limit. I'll just leave it at 12 volts instead of the full 18, and we'll see what current it pulls when I hook it up. Here we are, 12 volts, and we'll just tap the old positive on and just see what happens. And we've got nothing. Look at that. So we can turn the current right up now. The brief 100 milliamps that popped up was of course the input capacitor charging. So with that not drawing any current, the thing must be in standby. Let's have a look at what voltage may be present on that regulator. We'll jam our negative onto the plug there because that's negative. Just going to go to the side of the barrel because it's sticking out of the socket. It's nice and easy. And we will have a look at the switching regulator there, and we have 5 volts. Cool, so that's working. We have our 5 volt rail. Let's plug in the front display. Okay, now we'll reconnect the power. Standby light. Now we'll turn it on. Hey, look at that. Cool. Mode will be whatever the input mode is, I suppose. But here we are, HDMI, auxiliary. Oh, it does have radio. Okay, so that is a tuner IC. Off. There we go. Too easy. Fully reassembled. Let's see what happens. Load. I wonder what it's loading. Why can't we have volume? Here we go. Well, easy fix. Thanks for watching.